Hi guys, welcome back. We're going to continue talking about relations and functions in this chapter. Go ahead and hop right into 4.3, writing functions. Okay, so we need to determine a relationship between the x and y values, and then we're going to write an equation. So what I would do here is I would say, okay, we're going from x to y. Okay, what did we have to do? So I would say, well, to get from 1 to negative 2, I could subtract 3. I could also multiply by negative 2, okay? So I want to think of multiple ways, and sometimes it'll be straightforward where it will only be one step, and sometimes maybe you'll have to times it by 2 and then add 1, right? So you might have to think outside the box, but start with the basic ones. There's no reason to stress too much. So if I go to the next one, to get from 2 to negative 2, I can subtract 3, but I cannot multiply by negative 2 to get it. So subtracting 3 is looking like my best bet here. Well, 3 minus 3 is 0, in fact, and then 4 minus 3 is also 1. So I'm doing the same thing every time, so I know it's minus 3. So what I'm doing is I'm doing x minus 3 to get y. So I could write my equation x minus 3 equals y, or you could write y equals x minus 3. Those would be the same thing. Okay, so we're looking for the patterns today. All right, so let's look at this next one here. So our x and y's are a little bit different, so I'm going to say, okay, what takes me to get from 1 to 3? Well, I could multiply by 3. Whoops, I can't write today, sorry. I could also subtract 2. I could also do 2 times 1 and then add 1, right? Because 2 times 1 is 2 plus 1 is 3. Okay, so let's see which one works. Well, I know to get from 2 to 6, I multiply by 3. Subtract 2 is definitely out, okay? And 2 times 2 plus 1 would give me 5, so that's definitely on. So let's see if times 3 works for the rest of them. And it does, right? Okay. So then what I'm doing is I'm taking x, we're multiplying it by 3 to get y. So I would write this as 3x equals y, or y equals 3x, because we usually don't write x times 3, okay? All right. So we're going to identify independent and dependent variables, and this can kind of help us just get a feel for where things are in the graph, and what x and what y would be, okay? So our first one is, in winter, more electricity is used when the temperature goes down and less is used when the temperature rises. So we want to identify the two things that are changing. So we're using different amounts of electricity and the temperature is going up and down, right? So what I say is, okay, which one depends on which, okay? So the more electricity I use depends on the temperature, right? So the electricity is my dependent, okay, because that depends on how much the temperature is changing, right? And my temperature is independent. And you can think of it too, like we have no control over the temperature outside, right? But we do have control over the amount of electricity we use, okay? So the cost of shipping a package is based on the weight. Well, the two things that are changing is the cost of shipping and the weight, okay? So the cost of shipping depends on how much the package weighs, right? So the cost of shipping is my dependent, okay? Because that depends on the weight of the package, okay? So Ron walks, the faster Ron walks, the quicker he gets home, okay? So this one's kind of tricky because the faster Ron walks, that's his speed, right? And the time he gets home is the other variable, right? So sometimes they kind of trick you into thinking, okay, like what does each one mean, okay, for our two things. So our speed, or I'm sorry, the time we get home depends on our speed, right? So our time is the dependent because that's what's going to change, and our speed is the independent, okay? Because the time we get home depends on the speed that we're going. All right, wrote myself a little note so I got that correct. All right, the dependent variable is a function of the independent variable, okay? So basically what that's saying is y is a function of x. So we use this fancy function notation, and a lot of you are going to say, Miss Haas, why can't we just use y? And I understand, but there are some benefits to using this. So what all that means is, instead of writing y, we can write what we call f of x, okay? So this symbol is f of x, that's how we say that, okay? What that does is it shows that x is our variable that we're using, okay, instead of having a second variable, okay? It's just denoting that it's a type of function, okay? So if I were to give you these equations, okay, and I want to rewrite them using f of x. So basically, instead of writing y, we're going to write f of x. So I'd have y, which is f of x, equals 5x. So what this is telling me is I have some equation and the variable is x. So this is a function of x. Okay, so go ahead and try this one. How would you write it? So this would be f of x is equal to 3x plus 2. Again, all this is saying is my function has the variable x, okay, and that's the variable we're using. Now again, I know some of you you're fighting me already, okay, but we're going to show you how and why this works in a little bit, okay? So let's talk about this. So a lawyer's fee is $200 per visit for services, right? So we want to know the dependent and independent variables. So the lawyer's fee is $200 for services. So the amount that he costs depends on the hours that he works, right? So the dependent would be the hours that he's working, and the independent is the fee, right? Or the cost. And if we wanted to write an equation of that, we would say f of x is equal to, well, one visit would be $200, two visits would be $300, so on and so forth, right? So we're multiplying those. So we would say 200 times x, okay? And x would be the number of hours. Okay? All right, let's look at another one here. Okay, the admission fee to a local carnival is $8 and each ride costs $1.50. Okay, so we have our dependent and our independent variables. So the cost depends on how many rides we ride. So the dependent is the number of rides that we're going on, and the independent is the cost. Okay, so I want to write this as a function. We'll do it a function of r, for r is the number of rides. Okay, so it doesn't matter what variable we use in there. We can still use whatever letter we want, just like before. So I know that it costs $1.50 per ride. So to figure out how much money I'm spending per all my rides, right, I'd have to do 150 times r. And then I have to add in that pesky $8 that I had to pay to get in. Okay, this is kind of like the yoga problem we did a couple weeks ago. Okay. All right, now this is where the important things happen with f of x and why we use f of x, okay? Or f of r in this case. So evaluating functions. So we have this function f of x equals 5x, and we want to find when x equals 6 and when x equals 7.5. So what we do is we want to say, what is f of 6? Okay, so I know x is going to equal 6, so I'm going to put a 6 here. So in the rest of the problem, wherever I see an x, I'm going to put a 6. So I'd have 5 times 6, because I have an x here, right? Well, 5 times 6 is 30. Okay, so we do this because it kind of shows what we plugged in. We're saying, okay, we're plugging in 6 and we get out 30. Okay, so it's a notation that can kind of help us keep ourselves organized. Okay, now if we want to do f of 7.5, why don't you go ahead and try that one? So this would be 5 times 7.5. I don't have my calculator handy, so I'm going to do it old school. So 25, 35, 37.5. Okay. So that would be f of 7.5. Okay. Now sometimes they'll give it to you straight up where they just give you these two functions, okay, and they're what you're plugging in instead of writing x equals 6 and x equals 7.5. So again, notice that this variable we're using is t, and instead of writing t, they wrote 2 here. So in my problem, wherever I see a t, I'm going to write 2. So I have 2.3 times 2 plus 10. Well, 2.3 times 2 would be 4.6 plus 10, and I get 14.6. Okay, so again, it kind of just shows us what we're plugging in and what we get out. Okay, so that's why we use that notation. Okay, g of -5, go ahead, why don't you try that one? So we have 2.3 times -5 plus 10. Again, I'm just going to do my math off to the side here. Times 5 would be 15, carry my 1, 10, 11, and be negative, move my decimal over 1, so a negative 11.5. Plus 10, and when we subtract that, we're going to get negative 1.5. Okay, so I know this seems a little scary, but that's okay. We're going to get through it together. You can do this, okay? Have a wonderful day, and we'll talk to you later. Bye.